Okay, welcome all. This is going to be a print of the Cyrax dragon from Game of Thrones. And the real experiment here is because I plan on doing some highly precise parts using a basically the finest 0.4 millimeter print you can get off of a Bambulab at 0.08 millimeter layer height. I am also using the bamboo PVA support system, which should be the main focus of this today. Now, the idea is that we don't have any problems with the PVA. And the PVA is a water soluble solution. There is a lot of detail in Cyrax's head, which is on the plate, as you can see. And we're going to start the print and we're going to let it run. It's going to take about 2 hours. Sorry. Total time, 1 day, 6 hours. Okay, maybe extra fine is a little bit... Let me check that really quick. Let's go with the infill and see if we can't slow that down a little bit. That seems like a long time for the... I mean, how many tool changes do we have? 836? Wow. Okay, hold on. Let's maybe not try 100% infill. Go with me. 15. Get my wall loops. That's fine. Let's reslice it a little bit here. 1 day. It's the tool changes that kill you. And it may run it out of filament just because of the tool changes. I have to adjust the amount of purging that it does. I am going to set up the purge into infill when it comes to the support. Just because you want to make absolutely certain that you're purging into the infill, as opposed to just wasting it on the wipe tower. It's still 1 day. Okay, you know what? Who's up for a 1 day print? To see if we can do this. Or do we want to go with a lower resolution? So we'll go with high quality 12. Use modified versions. And then what we'll end up doing is, it should already be set up to purge into the infill. We're going to go into the others and look. I think it's under here. You know, by layer, obviously. Yeah, flush into infill and flush into support. So that should help. PVA is mainly the support material, so I don't know how much flushing it'll do. And I don't know if it'll flush water-soluble material into the infill. We're going to find that out together. So let's reslice this. We'll go for a 0.12 high quality. I wanted to make the print not last too long, just so we can kind of see how PVA is going to work. Now, when it comes down to me actually printing the high pass blades or any of the smaller blades, then yeah, I'll go for the highest quality as long as the PVA works. We're still looking at 20 hours. Y'all up for a 20-hour print if I put the right music in? All right, we'll do what we can. I think I have a couple tracks. I have to, I'll add some. So stick with me. We're going to spend 20 hours printing something. And we're going to see how PVA actually comes out. But first, before we start, let's do a standard. Let's do a standard. Not for strength. We could do an optimal. Use the same values. That's a 0.16, which is still a fairly decent layer height. And for the size of this model, that may be plenty. So let's go ahead and slice it up. We're down to 14 hours. Okay, let's do standard 2-layer. 0.2. And we'll see how much detail we get out of it. Especially since we're using the PVA, so we're not really worried about support overhangs ripping off small tendrils, because this model has a lot of spikes coming off the back and horns coming down the side. So okay, 11. We can do 11. I don't want to kill you guys with 20 hours time. Just because now we are looking at 336 filament changes, and then we'll weigh up the waste and see where we're at, and see how much waste can we get out of the system in order to kind of fine tune it, so we're not wasting so much material when we are doing material purges when switching. So we are using an engineering plate. I use hairspray. It works best so far. So let's see how it goes. Plate looks a little bit rough because it's got a couple layers of it has a couple layers of hairspray on it. So, but it works good. So we're gonna stick with it. So let's go ahead and send this to the print. We are using black. We are using PVA. And pray that the PVA doesn't clog up the extruder. Through the AMS, it tends to happen. Even without the AMS, it can happen. But I did dry it, so wish me luck, everyone. We're sending it over. Wait, what does it say? Please take the following. Damp PL. It'll tell you about. It'll give you warnings about it before you start in. So that's good. Yes, confirm. Please, confirm and send. It's sending. All right, we'll be off shortly. Oh, during the last update, I have to say, let me say something really quickly before we get going here, and then we'll go back to the music. The camera tends to shut off every couple of hours. Yeah, either unless I'm on the window or maybe I'm off the window. I don't know. After the last update in the Bamboo software patch, the camera does shut off. Thank you, Chihuahua. I appreciate the interruption. The husky's trying to eat her. So what I'll do is I'll go back and forth and I'll turn the camera back on and make sure everything's, if it shuts off, I'll turn it back on. It's not like I'm going to leave it here. So enjoy. Has to go through its setup process, so hang in there. As you can hear in the background, it is doing its pre-calibration at the moment. And it will do a flow calibration and then continue the print. The flow calibration has started. I tend not to use glue on the plates. I find that a thicker hairspray works better. You can put it on in layers, and then you don't have a lot of deviation from the glue in the bottom of the print when you're finished. The textured TPE plate or TPI plate, I usually don't use it. I'm usually using the engineering plate, mainly because I'm not really interested in textured bottoms when it comes to turbine fans. So stick around. It looks messy on the surface of the engineering plate, but it does tend to. The interesting part about the hairspray is that it's water soluble as well, so it's gonna come off with the support material. And I did print 2 rafts of support material underneath the actual model, so it shouldn't affect the model at all. It should come out fairly clean. I mean, it's going to be a little bit of a longer print than I had hoped for, but I think the results will speak for themselves, hopefully, if the PVA works properly. I am going by the recommended settings on Bambulab for the PVA, and then we will see how it turns out. As you can see, we already have some PVA stringiness happening. Let's see if we can get a successful print. I don't know what it is with this PVA. Following all recommendations, I still have that issue. And it looks like we already have a problem. There is something obviously stuck in the extruder. It thinks it's printing, it's not printing. I don't see anything coming out of the nozzle. That's the thing with PVA. So we're going to give it a quick check and then go from there. Okay, just as I thought, it looks like it's got a clogged extruder right off the bat. Thank you, PVA. So we will pause this stream and see if we can't get it started over. If I can't, then I will end it and then we'll try it again later. Looks like the PVA clogged the nozzle from the get, so none of the black even printed. Let me get this sorted out. I'm going to let you see what I have to go through with this. It should be educational. So I'm currently unloading the filament now to see what part of the extruder is jammed. There's a Hall sensor inside the head that'll tell the printer that there is filament in there, and if it's grinding away the filament because there's a stuck piece in the extruder, it's going to believe that it's going to continue printing when it's not. It's not going to continue printing. I mean, it'll continue printing, but it'll just sit there and not put anything out because it's stuck. And this seems to be an issue with PVA. Even though it's been dried, my moisture level in the AMS is only a 2, which isn't bad at all. This tends to happen sometimes, so we're going to get it fixed. And I never have any other trouble with any other filament. It's just the PVA. It may have been just a stuck cutter that wasn't registering as stuck, so it was buttoned up against that. So let's go ahead and run just a small black test cube to be sure. Let's hope this either pushes it through or it breaks loose whatever's in there. It could have been just the fact that that printer head was stuck, because sometimes that PVA gets sticky and won't let that cutter come back. But there's a sensor in there that'll let you know if that cutter's stuck. But if it comes back just far enough, it'll think that it's not clear, or think that it is clear. And then it'll start to print even though it'll hit that blade. Okay, the extruder is definitely clogged. The only problem is I have to shut the printer down in order to pull the extruder out. So we won't be able to see anything in there. Unless I have a light I can use. We'll see what we can do. Hang in there. These are the problems we want to try to figure out. Okay, the PVA caused the problem. I've got another extruder. Let's swap it out and see what we can do. Alright, yeah, guys, obviously won't be able to see what's on camera while I'm swapping the extruder. So we will end the stream here, and then we will come back, and I'll have the results. I'll put a short up showing where the extruder failed, if it was the PVA or the PLA, and we'll go from there. Thanks for watching. Sorry I didn't completely and totally finish like it was supposed to, but this seems to be a reoccurring problem with PVA. I know it's a water-soluble support material, but it's almost not worth the hassle. So, everybody, thanks for being here, and we will get the results of this up in a short or another video shortly to show you exactly what happened.